Hi everyone, welcome back. Welcome EK fans. We are back to our live discussion with Attila and Joe. I think you already knew them before. So Attila, technical marketing manager.
Thank you.
And Joe as a lead product designer in EK. And today we are going to cover actually the hot topics in water cooling, or maybe should I address the cool topics with hot guys?
Something like that, yeah.
Okay, so in the webinar we talked about the DDC and the D5 pump. So the difference, what is your opinion about those two pumps? What can you say to the guys watching us?
So the big thing that separates them instantly is the size. There are some loops where you're working in a tight case and you just simply don't have room for the D5. And there are other times where you have strict demands for the head pressure or for the flow rate from the pump. And both just have different characteristics, and it's picking the right one for what you need. Generally, the refined D5, if you have space for it, it's really nice. It's overkill when it comes to flow and more than sufficient head pressure for 4 blocks, 3 rads, easy. DDC, on the other hand, in a tight spot or with a really highly restrictive loop, these are a really popular option too. They do have one other differentiating thing which you must consider, and that's the D5 is actually water-cooled, as in the pump from the motor is rejected to the coolant, whereas the DDC is air-cooled. So you need to take care of that. You can't just pack it in a corner with no airflow, and the heatsink really helps. Some air moving over it, and it's good.
So we have actually one type of a D5 pump, but on the other hand, the DDC, we have, let's say, multiple options like 3.2, 3.1. What is, for someone, maybe it would sound like it's a version 1, version 2, but what's the actual the difference in the performance on the strength of the pump, maybe?
I would leave Joe to answer this question because I think he has more knowledge of the versions of this pump.
Yep, so on a DDC side, you have the common versions of the 3.1, the 3.2, and the 3.25. 3.2 and 2.5 are almost identical. One is PWM, one isn't, and they really deliver the maximum head pressure we see in any pump, even higher than a D5. They have a open, closed vane design on the impeller, whereas the 3.1, it uses a little bit less power. It's a bit slower, and it has an open vane design that's slightly less efficient. So the 3.1 is good for a simple loop. It's a little bit quieter, but the PWM spec of the 3.2 is the best all-rounder. You can run it slow, you can run it fast. That's really good. And as you bring it up, there is actually 2 specs of the D5. There's the D5 MX, which we use for fluid gaming kits and the older stuff when you upgrade it, and there's the full-fat D5, which have a similar difference between the 3.1 and the 3.2. All current EK products, all quantum products use the full power, the full-strength D5.
Okay.
Actually, going back to the versions 3.1 and the 3.2, the difference is also one is using a single cable header, and the 3.2 is using a separate Molex power cable and a separate cable for the speed and the RPM readout.
Yeah. Okay, so not so long ago, we actually launched a new pump, a VTX pump. There's actually a nice question right here. What about the performance of the VTX pump versus the D5 and DDC? What is actually the difference right here?
So the capabilities of the VTX sit alongside. It can deliver just the same characteristics, and it's a really well-refined pump. It's really quiet, so we're getting good feedback from initial testing. But for, let's say, extreme users, I think they'll appreciate the long-standing reputation that the Lang pumps have, and we hope that the VTX can prove itself in the coming years. So We're introducing it first in combo products, and then it will be soon available as a standalone. But really the thing we wanted to deliver with that was a DDC footprint, a compact pump with the refinements of a D5, so a really quiet bearing and a quiet motor.
So talking about, let's say now the standalone and the reservoir combos that we have, what is actually preferred when you start the let's say building a loop? Is it any difference if you choose a combo unit, or is it standalone? It's better. What would be the preferable choice, for example?
It is also easier if you would get a combo, because then you will have the liquid directly fed onto the pump, so you would be making no mistakes like running it dry for a few seconds, because all of these pumps are like water lubricated, so you have to have some water inside. Running them dry even for like 5 seconds could be damaging the bearing. So if you choose a combo and if you put liquid in it, there is much less room for error.
So it's safer actually at the end. Yeah. Okay, there's actually one question here for the 011 XL case. So we have a side distro plate with that, and there's someone asking if we can put a third 360p radiator in the back with the distro plate together.
With the side distro plate, the distro plate itself mounts to the side radiator position, so you can't. However, we have just introduced a front distro plate in the quantum line with a D5, and this leaves the side position open. It blocks front mounting of the fans, so you need to fit the radiator and the fans in the back, but you can fit an SE 360, P 360 on the top, and XE 360 on the bottom, all at the same time, which is actually massive for such a compact case.
Exactly, yeah. What about talking about, let's say, tubing? We have many options of sizes of the tubing. What is actually the difference? So thinner, thicker, is there any difference in performance, flow of the cooling, anything? What is the...
So there is literally no difference performance-wise using thicker or like thinner tubing. It is purely visual. So what do we like the most? Simply because we have all of these blocks. We have CPU blocks, radiators, and they all have the same hole opening on them. So even if you had a wider tube, it would then narrow down at each fitting. So basically, having a thicker tube doesn't mean anything. So it's purely visual and the visual choice of the user.
Okay, what about the reservoirs? So we have many options of sizes also. What about this difference in performance? So bigger, let's say, reservoir, any problems? Or let's say with only a combo, the standalone pump, is there any difference in performance choosing with those sizes?
So there's two factors to consider. One is when you're filling the loop. Obviously, a bigger reservoir, you'll have less times to fill it and cycle the pump on and off. If you can put practically, in a 400 ml tube, you can fit almost enough volume for an entire loop. So you fill it once, let it run down, and the loop's practically bled. With a small tube reservoir or a small flat reservoir, you may find yourself, I don't know, 10, 15 cycles if you have a huge loop, but this is all in the first day. After that, this difference goes away, and you just need enough coolant above the pump to keep it wet, to keep it full of coolant. The other effect the size has on the loop is actually the speed at which the coolant changes temperature. So if you have a high thermal mass in the components and in the coolant, then the loop will be stabilized effectively. It will take longer to warm up, but it will also take longer to cool down. So the net effect in the end is kind of negated.
Exactly. Actually, we have quite a lot of interesting questions. We are getting really into details, so there's a lot of enthusiasts right out there, and there's one very good question. So we have nickel plated, and we have like bare copper options to choose. The difference, I mean, not just the visuals, but is there any difference in performance or anything?
Basically, there is no performance difference because the layer is so thin that there is no difference in the actual heat transfer. It is mostly visual preference, but it is also maintenance difference. So there are still guys who would want to run non-specific coolants, distilled water, stuff like that. So if you want to run distilled water, then you can use copper blocks because you won't be damaging your nickel plating. But if you want to have nickel plated blocks, you have to use specially engineered coolant so that you don't damage the nickel plating on your block. So it is purely visual and also maintenance-wise. Cleaning copper blocks, it's much more easier. You can just use ketchup, citric acid, Coca-Cola, vinegar. So you could use these very basic stuff just to make your block look like new, whilst nickel, you would have to be much more gentle with the maintenance and the scrubbing of the block.
Yeah. So what about, maybe Joe, a question for you, push versus pull? So the fan's position, which is better?
Push-pull.
Yeah, both for sure is the best if you can do it. The most efficient is pull. I think that's contrary to most people's expectations, but the fan is able to utilize the whole surface area of the radiator much better because it's making a negative pressure difference, a vacuum for the radiator, if you will. This distributes itself nicely over the whole radiator. But when it's working in push or in pressure against the radiator, it tends to just utilize the area directly behind the fan. So you get a little bit more from having pull and push.
Of course.
But aesthetically, it's really nice to see the front side of your fan. I think everyone wants to see the blades and the RGB.
Of course, especially with the RGB lights, it's better to have it in the front, right? What about, we are getting covered like to the most components, radiators. Now we've mentioned, of course, white radiators. We have been asked a few times, but are there any plans for nickel-plated radiators or silver radiators?
There has been thought about many things about radiators, and we are still ramping up so that we update our radiator looks, design, performance. We have a huge challenge because we have so many types and sizes. So we have three radiator thicknesses. So we have the SE, PE, and the XE. And also we have 120 and we have 140 millimeter size radiators. So I think altogether we have like 40 radiators or something like that. So we would have to change it all at once, and this is a huge task so that we do it right. We have seen modders strip the paint of our radiators, and it really looks good, but making it as a mainstream serial production model is a bit more challenging.
Yeah.
So it's a really good idea. I would support it, but we'll see.
Maybe in future just have it separate, but we will never talk about that. I mean, we will see that. Okay, maybe make a step back at the beginning. So starting to build a custom loop PC, what tools are actually needed to start?
The best tool, I think I said it on the first stream, my favorite and best tool is the fill bar tool. It sounds really simple, but it gives you a really nice controlled way to put the coolant in. as well as to take it out. So if you make a mistake and something's gone a little bit wrong, and you can just drop the end and suck the coolant out, for me that's the most practical tool when building a loop. If you just need to get to change one component, then you can start to just piece it apart, get the coolant level below it, and carefully take it out. It's fantastic.
Yeah.
Other basic tools, the things I'm always taking around from my own tools is my bending cord. I've had it since the first PC I built, and I make the best bends with it. So
Yeah, so the tools actually matter.
I'm sticking to it. Yeah.
It like really depends. So if you are using soft tubes, basically if you buy a kit, you will get everything in it, including the filling bottle. I think that the only thing that you need is a Phillips head screwdriver, and that is only for the AMD version, because you have to remove the stock backplate so that you can use our backplate. But if you are on Intel and if you buy a kit, you literally don't need any tools. Everything is supplied inside the box. If you are going a step further for hard tubes, of course you need a heat gun, bending tool, which we also have, and the silicone insert, and a saw so that you can cut the tubes. And that's really basically it.
So, okay, what about, let's talk a little about fans. There's one question about the X3M fans. Do they come in 140 version?
This is a hot topic, obviously. We don't have any plans about doing the 140 size at this moment, but obviously demand is quite
It's massive.
Yeah.
We didn't see it coming. The X3Ms people absolutely fell in love with. So
Yeah, so we will, of course, we will think about it.
Yes.
We always listen to our customers in the end. If there's a big demand of something, we try
We'll
to
do
do
it,
it,
yeah.
of course, yeah. Okay, what about the, let's say, the temperatures? Someone is asking actually if he can cool the parts down below the ambient temperature in a build.
He can, but he shouldn't. So by using classical liquid cooling, you will never be able to cool it down below the ambient room temperature. There are ways that you can cool it down, like you can just take the radiator, dump it into a ice bucket, and you would get lower temperatures than the room. But then you would have other challenges because you would have moisture, condensation appearing on your CPU block, GPU block, and this could cause electrical issues with your motherboard or GPU. So if you want to do something like that, you should research more about extreme overclocking and how do they insulate motherboards and GPUs so that moisture damage does not happen.
Now, talking about, if you already mentioned the extreme overclocking, there's a question about liquid nitrogen cooling. We had an extreme series. Why don't we often do it anymore, actually, or do we have any plans for that?
at this moment, no. Simply, as the company has grown, we've reached such a big audience with our products now. From back in the days when we offered the SF3D line, SF3D. We've grown so much since then that we really don't want users getting the wrong impression of what this is for. It's really serious equipment. It's still out there, but not from EK. You really need to be experienced and prepared.
Yeah, exactly.
It's another level.
Yeah, so if this actually, it's an extreme level, but there's also one question of how actually to keep the temperatures actually in the best situation under load. What does it matter the most? So is it the fan speed? Is it the proper coolant? Is it the pump speed or anything? What actually matters the most right here?
the most that matters is the radiator size. So that is what the most influential thing is. The next thing would be the fan speed. So these two things are the most defining factors about what will be your temperature. Pump speed isn't all that relevant, so you could also test at home that just running your pump on high speed and low speed will not impact performance all that much.
Yeah, okay. So I think we can talk a little bit about this product right here. Joe, you will be the perfect guy to talk about. Can you tell about what this is? What is this big project right here?
So this is a Nano 90K, which was built originally just to show off the quantum line. So it really puts all of the blocks, all of the fittings, all of the intricate details that we have at the time right in the center of attention. And really it allows any user to put together the most beautiful and elegant system. In a strange way, it's really focused around ease of use, and so that everybody can get such a clean build as this one. So going beyond the case itself, there's also a distribution block that the motherboard mounts to, and this helps you get the coolant where you need it, get your tubes lining up perfectly with the GPUs and the CPU, and it's a formidable way to tie everything together. And the exterior portion of the case houses the radiators and the pumps, and this is started life as a Invert 909. We made it wider to fit the biggest radiators. This can fit two XE480s at the same time, two D5 pumps in the bottom, so it's as overkill as it gets to show off your overkill hardware.
Yeah, and actually we still have this product able to you are able to buy it in our web shop, and it's a limited version actually. So if I'm right, there's only about 120 pieces left, something like that. So if you want yours, you have a chance right now. Yeah, exactly. There's one interesting question about maintaining your loop. What does this mean?
So you have to start off properly so that you can maintain your loop. So that you have to start off with purpose-made coolants, and we will be repeating this over and over again because the easiest way that you can screw up is that to use a non-purpose built coolant inside your loop. So algae can grow and lots of things can go bad. So that is the first step, that you use a purpose-made coolant for liquid-cooled PCs. Secondly, EK recommends changing the coolant at least once a year. This is not necessary, but it is a good starting point that you have a healthy loop, because it would just lose its basic abilities. So refreshing it would make it sure that it would keep its basic functions. We had cases where people have been using their liquid for 4 or 5 years without any issues, but they were quite lucky. So best thing is that you just replace your coolant once a year and you will be happy. There are also some people who love to change colors, so they would be changing coolants more often. So this is really not an issue.
And regarding to the colors, because there's also one question right here. Someone says that has 3 different colors. What about changing the colors? Is there any problems for the radiator or the, let's say, the blocks or pumps if you change different colors or different manufacturers of let's say, coolants? What is the effect? at the end from that?
I would not recommend to switch between manufacturers too much, and you can change color as many times as you like, but you will make a lot of cleaning work for yourself if you choose to go from red to white, because you're going to end up with pink if you don't get every last speck of red out.
Yeah.
That's of course possible, but it's going to mean a lot of flushing, disassembly of intricate parts. Maybe not everyone's ready to do that. As you say about maintenance as a whole, there's a lot of standpoints on this from our users. You can build a loop with all acetal, with ZMT tube, clear coolant, and it's going to run happily for a long, long time. But you're also not going to notice when it changes aesthetically. But if you have a bright, vibrant color, a solid color, everything plexi, everything seen, when it looks a bit different one day, you notice instantly.
Yeah, and talking about manufacturers, of course, when you change, let's say the manufacturer, it's important to read that it's what the coolant consists from. So the what's inside and everything, so it doesn't damage the water blocks and everything else. So of course, EK water blocks, the best go with EK cryofuel and so on. So that's the normal thing. Okay, we talked about this 909 EK. We also have a 303 here, 303 EK. What can you say about this product here?
So it's essentially a baby brother. The functional elements which apply are all the same, really. We have a distribution plate to aid the use of coolant, and actually, I would say this is a little more focused on the exterior look. You get the distribution plate on the front surface. It really shows it all off, and when you delve inside, you can see a beautiful system too, whereas the 909, that's all about the inside.
Okay. So what about the radiators? We touched this topic before, but the thickness.
Yeah.
So when should I go, let's say, with a thicker radiator? What is the difference? What is important when choosing the right size of the radiator?
I think we have already touched on this, but we can repeat it once again. So if you are looking for silence, you should look for slim radiators, and you should put in there as much as you can slim radiators inside your build. If you are looking for maximum cooling power, you should go for the thick radiators, but you have to be ready that you would have to run your fans at a higher speed, which also means more noise. So if you have a workstation PC or like something that, and if you really need the highest possible performance, you can buy a thick radiator, and you would have to run your fans on a higher speed, or you would have to use push-pull so that you can optimally exploit all of the performance from the radiator. But if you want a silent PC, you should get the biggest radiator and just use fans on a lower speed.
Exactly, so it has less dBA at the end. Okay, what about the rotation of the CPU block? We know that, for example, on the Intel platforms, we can rotate it in every direction we can. What about performance regarding that? Is it changed or different if it's rotated into different way?
Yeah, definitely. Although it can fit in all four orientations, the effect on the cooling is quite noted, because the shape of the IHS itself and the shape of the dies, the die layout of the chip, is not the same in both planes. Intel's 1150 and 2066 chips, they have the die orientated vertically, and we get the best results from having the inlet of the block aligned parallel to the dies. So the whole length of the die is receiving cool coolant immediately, and the ends of the cooling fins, which are naturally less efficient, they are off the side of the die, because the heat spreader doesn't actually effectively spread the heat throughout the whole thing. There'll be quite a big difference in surface temperature from the middle to the outside. So it's important to concentrate the mounting pressure and the coolant correctly. And our blocks are optimized to do that if you use them in the orientation we suggest.
Exactly, yeah. So talking about the, yeah, sorry.
I would just like to add something on this topic. I mean, obviously, you can flip the block because liquid cooling itself is like so much better than air cooling per se, that even if you flip the block just so that you can build your loop more nicely, you wouldn't be losing all that much performance. Of course, if you want the best performing setup, you have to follow the manufacturer's guide.
Exactly.
I think that brings up a really another good point, and that the loop as a single entity is all about balance. So you can't make up for a deficit that you've created. If you're hunting for every last 0.1 of a degree and you rotate the CPU block and think, I'll add another fan and that will fix this, or I'll add another radiator. No, unless you've got the heat from the CPU to the coolant, you can't take more heat from the coolant. So every stage, if you want to get everything correct, has to be balanced, and you can't just go overkill on one characteristic. But one thing can make up for another, so you can use radiator area, as in lots of rads or big rads, to make up for slow fan speed. So you really have to balance everything, but the beauty of liquid cooling is that decision is in the hands of the user.
Yeah, exactly. So the details actually really matter at the end.
For sure.
Okay, talking about the coolants, for example, we've talked before that we have copper, nickel, and so on. So these are metals which usually tend to corrode sometimes. So our let's say coolants, do they have all the protection inside to prevent the corrosion or also any damages inside the loop, for example?
This is a very interesting topic because we have been fighting with users who are using only distilled water. So I am always mentioning cars. So even if you have cars which have aluminum blocks, so it is a single type of metal, you still have to use special coolants which are recommended by the manufacturer so that your car will be running nicely and smoothly for a long number of years. So it is the same for liquid cooling as well. If you want to have everything running nicely without any damage for years and years, you should use the manufacturer recommended coolant inside your loop. Basically, if you would use non-specially designed coolant on a nickel-plated block, you would soon start losing the nickel plating itself, and it would look, well, a bit ugly. Basically, you wouldn't be losing performance, but liquid cooling is about aesthetics as well, and you would be losing that nice finish of your block, which is really a shame. So this is why. And
the main point is just stick with EK parts and you will have no problem at the end. Okay, I have like a break question right here from Joseph Glover.
Ooh.
And
Hi, Joe. Hi, Joe.
Actually, he just wants to know what shampoo do you use, Joe?
No commercials.
Wow. Wow.
We are not actually able to express any brands here, but he uses the best one.
Yeah, actually, Cryfuel.
Okay, that was fun. So, talking about radiators again, do we have any plans for thinner radiators, like, I don't know, 15 millimeter maybe?
Not really.
It's not on the books, so to speak. It's a difficult design constraint to work with.
Restriction-wise also.
Yeah, but we are adding lots of little products tailored to small form factor builds, and this is something that will get considered when that area is fleshed out, so to speak. We have the direct blocks now with the ports directly on the top rather than a terminal, and we're going to have some small fittings, which you'll see.
I mean, basically, if we want to touch so much on this small form factor, I think that we would be making thinner fans before we would be making thinner radiators, because you have to have some beef inside it.
And that is
Radiator.
also a question. So the fans,
Ah.
thinner fans.
I would love if we would make thinner fans, but this is also a decision up top. So maybe yes, maybe no. I will be fighting for them. So who knows? What I can tell is that I have been fighting for white fans, and I can say that white fans will be coming soon.
That's a great news, actually.
Yeah.
Okay, let's talk a little bit about flow direction, maybe. Is there any performance difference if you invert the flow direction?
Yep, there is a maybe not noticeable in the grand scheme of it if you're just monitoring the temperature of your component. The room probably varies temperature more than you'll cause by reversing the flow, but there is a little difference. All of the blocks are optimized for one direction. All GPU blocks are optimized for flow to enter at the rear of the block closest to the I/O, and CPU blocks generally follow the same. We now have the reversible cooling engine in magnitude, so you can switch that. And like I said earlier, if you're hunting every decimal of a degree, do it right, but because you can't make up for it elsewhere, but it's not essential.
And if we're talking about the flow, let's say, so we've talked in the webinar already about parallel and then let's say serial. So the difference and which one is better? Again,
it is also a user preference. So there are no many, not a big difference. But if you are using a multiple GPU setup where you have more than 2 GPUs, then you should be using parallel flow inside the GPUs so that your loop is not so much stressed with the restriction. But since multiple GPU setups are kind of dying out because single GPUs can like run games very effectively, these setups are mostly used only in workstation scenarios.
yeah. So what about for example, the fans? 120 versus 140, is it at the end only the decision because of the size of the case, or do actually fans at the end have way much difference? For example, 140 is bigger, the performance and so on. So what does it matter here?
That's a really good question, and there's lots of characteristics at play, again, like with most things. But the key factor I'll maintain is the frontal surface area of the radiator. And with a 140 millimeter fan, because more of that surface area is blade, you actually can get a bit more from 140 format radiators. But most cases are really nicely designed around 120. Yeah. And
yeah, so it's
there's nothing to lose. It depends what you can fit.
Exactly, yeah. Okay, so we've touched before this 909 case, and we can see that the cable management is really good, really nice here. Do you have any plans about cable reduction, for example, on that field?
Not really. Cables for now are a must. So unless we have changed standards, we will have cables. But this is a more serious question for the Intel, NVIDIA, and all of these guys who are making hardware, because GPU cards use a significant amount of power, and this is why we have these additional cables, because they need more power than they can get through the slot itself. So until there is some big change on how these GPUs are made, we will have cables. But fortunately, we can have nice cables. So
you just have to take a lot of attention to that if you want to have it look like this. Okay, so with this talk right here, we're going to finish right now because we are on a schedule with the next topic in, let's say, in 10 minutes. So thank you guys. Thanks everyone for watching. Stick with us because in the next 10 minutes we'll be talking about FluidWorks for actual professional users. So this will be interesting topic. So thanks a lot.
welcome.
Stick with us and talk to you.
Bye.
Bye.
Bye.